This is Aditya. Today I'm going to walk you through the project which I've picked as part of the Managing Machine Learning project for the peer graded assignment in Coursera. So this is the typical agenda. We'll start off with the opportunity evaluation. Then we will see the different aspects of the CRISP DM, how it is impacting the problem statement and the opportunity which we have. And then the solution validation plan, the ML system design aspects of it, and risk involved in the production. So from the opportunity evaluation perspective, the problem is about using a machine learning model to automatically generate personalized and actionable feedback on student writing assignments based on specific instructor-defined rubrics and learning objectives in order to reduce the manual grading burden on educators and provide timely, constructive guidance to the students. So why this is suitable problem and how does ML help? Um, Significant pain point for educators. So grading writing assignments is a time consuming and often subjective task for the educators. Automating a portion of this process can free up their time to focus on the high level teaching strategies and individual student needs. Potential for scale and consistency. ML models can process a large volumes of assignments consistently, providing standardized feedback that might be difficult to maintain manually across many students or different graders. Targeted and actionable feedback. So by aligning the ML model with a specific rubric and learning objectives, the feedback can be more focused and helpful for the students compared to generic grammar checks. Feasible with available data and techniques. With the advancements of NLP and deep learning, building models that can understand and generate text is becoming increasingly feasible. There's also a growing availability of anonymized student writing data and rubrics, which can be used to train and evaluate the model, and it will have a positive impact on the student learning because of the timely and personalized feedback, which is crucial for the student's progress. Coming to the CRISP DM for the business understanding part, the initial phase focuses on understanding the project goals, objectives, and requirements from business perspective. So the core objective is to reduce the manual grading workload on educators and improve the timelines and personalized nature of feedback for the students. So this frees up the educator time for higher value activities. So assessing the situation, resources, which we need, availability of student writing samples, existing rubrics, and instructor feedback, computational resources, human expertise, such as educators, data scientists, NLP specialists. Constraints, data privacy, anonymization of the student data, ethical considerations, fairness and bias in feedback, explainability of feedback, technical limitations such as computational resources, latency for real-time feedback. Assumptions, instructor-defined rubrics are clear and consistent. Student writing exhibits patterns that can be learned by a model, and instructors are willing to adopt an automated feedback system. From a data understanding perspective of CRISP DM, collect the initial data, student writing assignments like essays and reports, corresponding instructor defined rubrics, human generated feedback and scores on these assignments, potentially anonymized student demographic data um, to assess the bias. The next part is describing the data, like examining the data properties, format of assignments, number of assignments, characteristics of feedback, length, specificity, tone, focus areas, rubric structure and feature. Explore the data, like analyze distribution of scores across rubric categories, correlation between assignment features and feedback types, common errors or areas needing improvement identified in the feedback. Verify data quality, like assess the cleanliness and completeness of the data, missing feedback or rubric data, inconsistent formatting in student submissions or rubrics, potential biases in human generated feedback based on student demographics or writing styles. Coming to the data preparation part of the CRISP DM, selection of the data, filter relevant assignments and feedback pairs, exclude data that is incomplete or low quality, cleaning the data, handle missing values in the feedback or rubrics, correct errors in the rubrics or scores, standardize text formatting, construction of the data, feature engineering, like extract meaningful features from the student writing, example grammatical complexity, vocabulary richness, sentence structures variation, adherence to an argumentative structures for essays, presence of keywords specified in the rubrics. Labeling, like converting human generated feedback into structured labels for training the model. This might involve classifying the feedback into categories like grammatical error, lack of evidence, unclear arguments. Integrate data, like combine information from various sources into a cohesive data sets. Format the data, like convert text into a numerical expressions or representations. Example, word embeddings like word to vec suitable for the chosen machine learning algorithms. The modeling part of CRISP DM, select modeling techniques. NLP models specifically fine-tuned for text generation and summarization are ideal for generating feedback. Additionally, text classification models can be used to categorize specific errors or strength based on the rubric categories. Generate the test design, split the data sets into trainings, validations, and test sets. Cross validation techniques can be used to ensure robust evaluation. Build the model, train the chosen models. Example, fine tune a pre-trained transformer model on the prepared data, mapping student writing to the feedback and scores. Assess the model, evaluate the models on validation set using metrics such as feedback quality, accuracy. Evaluation part of the CRISP DM, compare the automatically generated feedback against human generated feedback and potentially conduct A by B testing with a group of students to measure the impact of automated feedback on student learning outcomes. Analyze the accuracy of identifying strengths and weakness across different rubric criteria. Assess the reduction in grading time for educators. Review process, reflect on the entire project lifecycle, identifying areas for improvement in data collection, preparation, or modeling. Determination of next steps based on the evaluation, decide whether to deploy the model, refine the model further, or explore the alternative approaches. Coming to the deployment part of the CRISP DM, integrate the ML model with the learning management system or a dedicated platform for writing the assignments. This may involve developing an API or a user interface for accessing the feedback. Plan monitoring and maintenance. Regularly monitor the model's performance on new assignments using the defined metrics. Establish a feedback loop for instructors to flag incorrect or unhelpful feedback, which can be used to retrain or fine tune the model. Implement mechanisms to detect and address data drift. Example, changes in the student writing styles or common errors or concept drift, which we will see in the next slides. Produce final report, like document the project findings, methodology, results, and recommendations for the future iterations. Review the project, conduct a project retrospective to identify successes, challenges, and lessons learned. Solution validation plan. For the iteration 1, select a sample data set for the potential solution evaluation. For the iteration 2, mockup based on historical data, build a mockup. Iteration 3, use heuristics and past experience to provide feedback and grading. For the iteration 4, build simple model to compare the outputs with previous iterations. For the iteration 5, use CRISP DM to refine the model and add more features to enhance. For the system design perspective of machine learning, cloud versus edge, I would prefer hybrid, given the data privacy. And in some cases, we need immediate results, and in some cases, delay is acceptable. Hence, latency varies. Offline versus online learning, depending on the nature of a graded assignment and priority, we can use both offline and online learning. Batch versus online predictions. On the spot exams or evaluation needs online predictions, whereas for the assignments, we can switch to batch. Potential risk in production, for the data drift, change in the student writing style, students common errors, example grammatical mistakes, unclear arguments, lack of evidence might change over time or across different cohorts of students. Influence of new learning objectives or curriculum changes, that's from a data drift perspective. For the concept drift, evolving instructor expectations. So instructors may subtly or explicitly change their criteria for evaluating writing over time, possibly emphasizing new aspects or adopting different interpretations of existing rubric criteria. A model trained on past instructor feedback might no longer be accurate to reflect the current expectations for high quality writing. Shifts in the pedagogical approaches or writing theory. So new theories about effective writing instructions or pedagogical strategies might emerge, leading to different approaches to provide feedback. Impact of the external events on writing context. Societal changes or external events might influence the context in which students write, leading to shifts in acceptable writing practices or the interpretations of written expressions. For example, a global event might alter the acceptable tone or content of written responses in certain subjects. Thank you.